Activity 14.7 is the probability of independent and dependent events. So we're just going to talk about theoretical probability from here on out, and we're going to look at the difference between independent and dependent events. So suppose you have a bag with 4 red, 6 blue, and 8 yellow marbles. Okay, they're missing a blue one. I'll add the blue one. Example 1, what is the probability of selecting 2 blue marbles in a row if one marble is selected, drop back in the bag, and then a second marble is selected? So the solution is that the probability of drawing a blue marble in the first draw is 6 out of 18 or 1 out of 3. Because if you add 4 plus 6 plus 8, I get 18 total. That makes it the denominator of my probability. If you want blue, 6 out of 18 are blue. If you put the blue one back in, you still have 6 out of 18, which is 1/3. So if you do one after the other, it's blue and blue. Then you will multiply 1/3 times 1/3 is 1/9. If you think about this process is called the probability with replacement because you take something out and you put it back in. If you take out a blue one, but you don't put it back in, it changes how many marbles are in your bag and the possible number of marbles that in this example could be blue. So the first blue marble still has a probability of 6 out of 18 or 1 out of 3. But if you don't put it back in, the highest possible number of blue marbles would be 5 out of 17 because you've kept the one out. 5 out of 17, we can't simplify, so we're just going to multiply. Remember, multiplication of fractions straight across. So it would be 5 out of 51. This process is called without replacement. So in any problem, you want to pay attention to the wording of with and without replacement. So where does independent and dependent events come in? Independent events in a multi-stage experiment, remember multi-stage is you do 2 things. We pick 2 marbles. Is that the outcome of one event has no bearing on the outcome of the second event. This is where we have the process of with replacement, because if I put the blue marble back, picking the second marble is not influenced by anything. But if it's without replacement, we call that a dependent event because now the probability of the second one is dependent on not putting that marble back in. So the first one influences the second one. So of the 2 examples, example 1 would be independent, example 2 would be dependent. Okay, so suppose you had a bag with 4 red, 5 green, 9 black, and 6 blue. What's the probability of each? First, you're going to have to find that denominator for your probability by adding all of them together. And I get 24 chips. That is your total. The probability of red is 4 out of 24, which would be 1 out of 6. Green would be 5 out of 24. Black would be 9 out of 24. To divide that by 3 out of 8. And blue would be 6 out of 24, which is 1/4. Okay, what is the probability you draw 2 red chips with replacement? So I want red and I want a second red. So out of 24, or it was out of 24, red is 4 out of 24, which is 1 out of 6. With replacement means I put the chip back, I have 6, and it'd be 1 out of 36 if I multiply them. If you do not put it back, you get red is 1 out of 6. And another red, but we didn't put it back, which means you have 1 red less, you have 3 out of 23. Let's see, we can simplify before we multiply because 3 goes into 6 2 times. Multiply your fractions straight across. 1 times 1 is 1, and 2 times 23 is 46. You can do 4 and 5. Let's look at 6 together. So suppose you drew 3 chips. What's the probability that they're all blue? So I want blue, blue, blue. Blue to begin with was 1/4. I put it back in 1/4. I put it back in 1/4, which is 1 out of 4 times 4 is 16, and 4 times 16 is 64. But what if we don't put them back in? 1/4. But now we had 6 out of 24. That would be 5 out of 23, 4 out of 22. So you literally have to picture, you pick one out, you keep it out. That diminishes the numerator and denominator by 1. You keep that one out. So now you only have 22 left in your bag, and 4 of those could possibly be blue. Let's see, 4 goes into 4 once. I'm going to simplify that first. So I get 5 out of 23 times 22 is 506. And we leave that. And then again, I think we can do number 8.